Solving rationals. This lesson incorporates a lot of different math skills that we have learned throughout our math career. And so I will be pointing those out to you. And then basically, I'm going to teach you like one thing new. But depending on who your algebra teacher is and how they taught you solving equations when you had fractions, it might not even be new to you. So let's dive into this and I don't know, let's go. All right, here we go. So the first thing is I want you to solve the first two equations. So solve this equation here and that equation there on your own. Okay. Sweet. Hopefully you stopped and you solved it on your own and you get x equals 1 and x equals 1 for both of those. So why do we come up with the same solution? Well, notice a difference between these two equations. 3x plus 2 equals 5 versus 6x plus 4 equals 10. All I did for these two questions was take the first equation and multiplied it by 2. That's how I got this equation here. And I want us to notice that even though I took this first equation, so 3 is 6x, 2 times 2 is 4, and 2 times 5 is 10, even though I multiply them, we end up getting the same solution, regardless of me changing the equation, right? As long as I change everything about the equation the same exact way, then I am fine by multiplying at least. So then what happens to the second one? Well, this third one, sorry. Let's try to solve this and we'll do the same thing. We'll subtract 2/15 on both sides. Hopefully that's what you did. And then we kind of get this fraction. You have to make the same denominator, right? What if I didn't do all that? What if I decided that I wanted to get rid of these fractions? So this is the fractions that make this problem difficult. Well, the best way to get rid of these fractions is to multiply them by a number that will cancel out my denominators. So when I focus on my denominators, I have a 5 here. This 15, what is that? 3 times 5 and a 3 there. Well, what if I multiply my problem by 3 times 5? Because 5 would get rid of the 5s. The 3 will get rid of the 3s. Then I won't have a fraction anymore. Well, let's see if that's true. Say we're going to multiply the first one. So what do I have? I'm actually going to write this out so you can see it. I have 3 times 5 times x over 5. Plus, I'm going to multiply the second one. What do I get? 2 times 3 times 5 over, we already said we simplified 3 and 5, or 15 to 3 and 5. And then multiply the last one. So equals 1 times 3 times 5 over 3. Well, we learned how to simplify some fractions, right? 3 over 3, we made some 1s. So that leaves us with 1 times 5, which is 15. Which is not 15. 1 times 5 is 5. Making 1s, these 5s cancel out. That 3 cancels out. That gives me just 2. The 5 cancels out, and that leaves me with 3x. Guess what? Same problem as above. So sometimes what we can do is we realize we have a fraction and we don't really want to work with that fraction. If we multiply by the denominators and we make sure we do every part that's included in that equation, we multiply by the denominator, we no longer have the fraction anymore and we can solve with ease. And that brings me to today's notes. So here we are with this first example, and notice I have some denominator issues. Now this is complicated, right? It's not just a simple numerical thing. We have this k minus 6, and we have to remember that those are binomials, so we cannot just, cancel out this k is here to make this thing simpler. I can't just say, well, what if I multiply everything by -6 and then, go from there. I have to remember that these are binomials, and then they have to stay together. Well, I do want to get rid of that binomial. I want to be able to cancel out just like I did that 3 and that 5. So I am going to multiply still. That doesn't change. I have to make sure I multiply the entire problem. And I'm going to multiply it by k minus 6. And that k minus 6 will allow me to get rid of this k minus 6. And so that denominator will go away. Well, I have another denominator. I have this 3 plus k. Now, I don't like 3 plus k. I prefer k plus 3. So I'm going to write k plus 3. I just know that they're the same thing. And so now I'm going to go ahead and start distributing. So K minus 6, K plus 3 times 1. Well, that's just K minus 6, K plus 3 times 1. That's just 1, right? That goes away. And then I multiply the next one. Well, I don't want to have to write all that out like we did over here, right? I don't want to. Now, if you need to, you're more than welcome to. I do want to recognize that I can see that the K minus 6 will cancel out on both of those. So what does that leave me? With the negative sign that's there, K plus 5, K plus 3. And then I distribute the last one. And again, I see the 3 plus K is going to cancel out from here, right? So I don't want to have to write that down, that I'm doing all of that and canceling it. But I remember through some mental math that those two things will cancel out. And that leaves me with negative 6K minus 6 equals 0. So now what do? We start distributing. Now, I want to point out to you that the only part that's going to be new this entire lesson is the fact that we have to multiply to get rid of our denominators. And that's only if your teacher didn't teach you that way in Algebra 1. So now we distribute. We've learned how to distribute already, right? That's K times K, which is K squared. And then, actually, I want to change colors. Sorry. There, K times K, which is K squared. K times 3, right? We know how to distribute. So I'm only going to do this first one, and then I'm going to keep it going. Maybe I'm not going to do the first one. There we go. K, negative 6K, and then negative 18. And now we need to remember that this negative sign is there, but I'm going to go ahead and put the negative, and I'll put parentheses, and I'm going to distribute this. All right. And as you can see, I've already stopped working on that. And distribute the last one. So why did I just write that negative down? That negative is going to get multiplied by everybody in here, right? So we want to be careful on things like that. That negative has to get multiplied by everybody. So when it comes to subtraction, just be mindful that it changes everything that's attached to that part of the problem. So I'm going to rewrite everything else, distribute that negative. Actually, I'm going to combine my like terms here. Let's do that. So that's a negative 3K. And then minus a K squared. That's going to be 8. So minus 8K minus a 15 minus a 6K plus a 36 equals 0. All right, don't forget that equals 0 there. And then I'm going to combine some like terms, and we're going to keep going and solving this, okay? So that's our goal now, is to solve this. So this K squares, they cancel out. Negative 3K minus, is that negative 11K, negative 17K. Negative 18 and negative 15 is a negative 33, plus 36 is a 3, equals 0. And then we solve, we subtract 3. And we divide by negative 17. And we're done. We did it. That's it. So what is important? I know this looks like a lot of work. Is that the only thing that's new here is that we want to get rid of our denominator. So we multiply by the denominator. That's going to help us get rid of everything. Now, we don't want to make it too complicated. So we have to be careful. And you're going to see that later on. All right, so let's try the second one. So what do we have in our denominators? Because I want to get rid of it, so my focus is going to be on my denominators. I have an 8D and a D minus 15, right? This 8D, they're both the same, so I don't have to multiply it by two different 8Ds. I just need one. So 8D and then the D minus 15. And then we start worrying about what cancels things out. So these 8Ds cancel out, so I'm left with 5, D minus 15. The 8Ds again cancel out, so I'm left with negative 6, D minus 15. The D minus 15s cancel out, so I'm left with negative 1 times 8D. Let's get to distributing. So we have 5D minus, what's that, 15, so 30, 60, 75. Negative 6D, 30, 60, 90, so positive 90. And then negative 8D equals 0. right? Just FYI, we didn't multiply that one. That is just 0. I think I ran out of room and didn't even write it. Didn't even think to write it. That's 0. Okay, combine like terms and get ready to solve. So let's see, I have negative 1D, negative 90. Negative 75 plus 90 is positive 15 equals 0. Subtract 15. Divide by negative 9. And then I can reduce that, and that gives me 5/3. Sweet. Again, our goal is to get rid of our denominators, so we multiply by what's in the denominator. And like keep it as simple as we possibly can. Once we multiply those, whatever cancels out, we don't need to write it. We distribute, we solve. Last one. Actually, I'm going to do one more with you because it's something my students have been having a hard time with, so I do want to go over that question. So what do I see? Well, I see I have this like trinomial. And so we haven't been dealing with trinomials. A lot of times when I say trinomial, I factored. So I'm actually going to do that now. I am going to factor that trinomial to see what it's made of, because that makes a difference in our problem. I'm going to go ahead and change that to w plus 7, because why not? Okay, so when I factor this out, I get a w plus 7 and a w minus 1. Now, let's focus on our denominators. What do we want to get rid of? And that's in our denominator. Well, the w plus 7. So that w plus 7 would cancel out this one and that one. And then what? The w minus 1. That w minus 1 will cancel out that w minus 1 and that w minus 1. So notice how if we factor first, we see that we don't need a lot of things to get rid of it, to get rid of our denominator, right? So we want to just be careful and factor first. All right, so back to the case, I multiply the first one. The w plus 7 and w minus 1 cancels out, so that just leaves me with 13 minus w, and then w minus 1 would cancel out, so that leaves me with a w plus 7, and then equals negative 5. Make sure you know that I multiplied these out. The w plus 7 would cancel out, so that leaves me with a w minus 1. Sweet. Combine like terms, or distribute. So 13 minus w squared minus 7w equals negative 5w plus 5. Now our goal is to solve this, and I see that I have a w squared. So that lets me know that these are going to be quadratics. So I needed to say equals 0. So to do that, I have a couple options here. I'm going to go with some options that my students had suggested. The first thing they suggested was to rewrite this in proper order. So we're going to put that w squared first, and then the 7w, and then the 13. Okay. So then my student suggested, hey, let's just make it equal 0. And so I was like, okay, how do you want to do that? Because there's two options to make it equal 0. We can move the left side, or we can move the right side. And they suggested the right side. So I said, okay. So we're going to add 5w, and we're going to subtract 5. And that gives us a negative w squared minus 2w plus 8 equals 0. So then we talked about it, and one of the issues that we noticed is that it's a negative w squared. Now, we can factor it this way, but I prefer to factor where my squared is positive. So then they were like, okay, well, we can move everything over. So they started to add w squared. And this is somebody pointed out, like, hey, if I'm going to move everything over, all it does is change my signs. So why not just change the signs of everything? And now we can go ahead and factor this and solve. Okay, so there's a couple ways that you can go about setting things up so it works out in your favor. You don't have to always go on the same route. It really just depends on what you're comfortable with. All right, so now we got to factor this. It's going to be different signs. The bigger sign has to be positive, and there we go. And then we solve this, set it equal to 0 and solve. So w is equal to 2 and w is equal to negative 4. Sweet. Now, last thing I just want to touch over is because I had a couple questions on the problem like this. And it's what's something, let's say 7 over n squared minus 5 over n equals, 12 over 4. Okay, not 4. 12 over 7. Now, our goal is to get rid of the denominator. And so a lot of my students were wondering, can I multiply it by n squared, n, and 7? And what I need you to understand is what n squared is actually made up of. So I'm going to rewrite this as the factors. N squared is just n times n. So with that being said, if I multiply this entire thing by n times n, it gets rid of my n squared, but it also gets rid of my regular just n. So you kind of want to be careful with that. Factor things out and try not to over multiply. If you can multiply by one thing and get rid of your denominator, leave it as that. So you don't want to multiply by too many things because then it gets complicated. Like you're going to make it life harder for you. So what cancels out in the first one? The n's do. So I'm left with just 7 times 7. What multiplies in the second, they'll cancel out in the second one, just an n, one n. So I'm left with negative 5 times 7n, because that's what will be left over here. One of the n's cancel out. And then what cancels out over here is the 7, so equals 12n squared. Now, I have no idea if this problem is going to finish factoring for us. I kind of just made something up so I can do this problem. It's what 12n squared plus 35n minus 49 equals 0. I do not think this is going to factor to anything that works out for us. I was just trying to make sure we understand how to simplify. So we're going to just stop there. I don't believe this is factorable. 7 and 7. 6, 2, no. Wait, this actually might be factorable. Hold on. Let's see. 6 and 2. 7 and 7, they're going to be different. That's negative 42. No, that's not factorable. No, I don't think so. It was fun while it lasted. I just made some numbers up. This is what happens when you make up problems. You can find out if it works or not, but I don't think this will work. Anyways, well, that's it. That's all. So this is non-factorable. We would have to do quadratic formulas for this. But the biggest thing I need you to understand is that you can break apart the n squared, and then you can multiply by that. Well, thank you so much for joining me, and until next time, bye.